full section work through. We're going to be doing section 3, that's the non-calculator math section, of SAT practice test number 5. This test was administered in May of 2016. Let's get that perfect score. Welcome to Perfect Score with Carl Rosenthal, where you come for the math tips and stay for the math cats. So in today's test, we have 20 questions, 15 are multiple choice, 5 are grid in, where you put in your own answer. For exactly half of these questions, I have included 2 ways of solving them, what I call the front door and the side door. The front door version is pretty much what they expect you to do, using algebra, using formulas, and the side door is using some kind of plug-in method, which we'll go over. So, without any further ado, let's get to it. We begin with number 1, and it looks like we have a linear function here. Which of the following is an equation of line L in the xy plane above? So, the first thing we should do is determine what the slope of this line is. Well, it is increasing, so we know the slope is going to be positive. As a result, we cross off A and B. A shows a vertical line. That's an undefined slope. B is a horizontal line, slope of 0. We're left with C and D. And it looks like we have y equals x and y equals x plus 1. The difference is y equals x has a y-intercept of 0. Y equals x plus 1 has a y-intercept of 1, which is what you see here. Excellent. The answer is D. Now, I'd like to go back and try this one with a side door method. You can easily pick any point on this line and see if it fits in any of these equations. I say let's pick one that's kind of out there. How about this one right here? Looks like it is 1, 2, 3 over and 1, 2, 3, 4 up. This point is going to be 3, 4, where x equals 3 and y equals 4. Let's see if these fit in any of these. Well, A says x equals 1. Clearly x is 3, that's out. B says y equals 1. Clearly y is 4, that's out. C says y equals x. 4 does not equal 3, that's out. And D says y equals x plus 1. Well, 4 does equal 3 plus 1. And that is the side door method. Let's move on to number 2 over here. Looks like we have a circle with 2 diameters drawn, and it looks like they are perpendicular. And we know that because we see this marking here, which means a right angle. The circle above has a circumference of 36. What is the length of minor arc AC? I'd like to remind you guys of the formula to find length of arc. And it's going to be a proportion. The central angle over 360, which represents the full circle, is proportional to the length of the arc over the whole circumference, which we'll write as 2 pi r. That is the formula for circumference. This one, I believe, is a little bit easier than this because we don't have to figure out what the radius is. They tell us the circumference is 36. And so that we can plug in for 2 pi r. So we'll say 2 pi r equals 36. And we know this central angle here is 90 because it's a right angle. So theta, which is the variable for angle, is 90. Let's plug that in. 90 in for theta over 360 equals arc, which we'll call x, what we want, over 2 pi r 36. This will be easy if we just cancel out a factor of 10 from the left side. Divide both top and bottom by 10. We get 9 over 36 equals x over 36. And if we want to get rid of this denominator, we multiply both sides by 36, cancels out both, and we have our answer, x equals 9. Great. Moving down to number 3. What are the solutions of the quadratic equation 4x squared minus 8x minus 12 equals 0. Well, let's start with the front door method. What this is begging us to do is to factor out a greatest common factor first. Well, if we look at these three terms, 4x squared, negative 8x, and negative 12, I hope what pops out is the number 4. 4 is a factor of all of them. So let's take out a 4. 4. What's left over? That's going to be x squared. Negative 8 divided by 4 is negative 2x. And negative 12 divided by 4 is negative 3. And if you take a look at this trinomial, we want to factor this, and we're looking for two numbers that multiply to negative 3 and add to negative 2. I hope you're thinking of negative 3 and positive 1. So we can factor this as x minus 3 times x plus 1. And of course, by the zero product property, we're looking for values of x that make these factors equal 0. So we say then x minus 3 equals 0 and x plus 1 equals 0. We ignore the 4 because 4 will never equal 0. 4 is 4. So if x minus 3 is 0, we add 3 to both sides, and we end up with x equals positive 3. And for this one, we subtract 1 from both sides, and x equals negative 1. Our answer is 3 and negative 1, or negative 1 and 3. Here we go. Now, let's try this again using a side door method. If you take a look at your answer choices, you don't have that many. You have positive and negative 1 and positive and negative 3. Our job is to try these out and see which one equals 0. This does take a longer time, especially with no calculator, but it is just as effective. Let's start with positive 1. We plug in 1 for x. 4 times 1 squared minus 8 times 1 minus 12. Well, 1 squared is just 1, 4 times 1 is 4, 8 times 1 is 8, and 12 is just 12. 4 minus 8, well, that's negative 4, minus 12, that's negative 16. That's not 0. 1 is out. So we cross off C and D. So now what? Well, take a look. A and B both contain negative 1. We can assume correctly that negative 1 is a solution. So all that's left is to try either negative 3 or positive 3 and see if it works. I always prefer to plug in positive numbers. Let's go ahead and do that. So now we're plugging in 3 for x. 4 times 3 squared minus 8 times 3 minus 12 equals 0. Well, 3 squared, it's 9. And 8 times 3 minus 12 equals 0. 4 times 9, that's 36. 8 times 3 is 24. And then we keep the minus 12. 36 minus 24 is 12. And 12 minus 12 actually is 0. 3 is an answer. Negative 1 is an answer. There it is. B is our answer. Moving forward to number 4. Which of the following is an example of a function whose graph in the xy plane has no x-intercepts? Well, vocabulary is very important here. And I want to point out what are some of the words we use for x-intercept. Solution, root, and we say 0 sometimes. A 0 is a point on a function where y equals 0. So if a function has x-intercepts, a function has zeros. I think we can automatically cross 2 off. B says it has real zeros. D also says it has real zeros. Now, C literally says the function has no real zeros. That should jump out at you as a right answer. If we look at A, a linear function whose rate of change is not 0. Well, if you think about that, rate of change means slope. If the rate of change is not 0, it means it's either positive or negative. Therefore, it's going to cross that x-axis. Moving on to number 5. In the equation above, k is a constant. If x is 9, what is the value of k? So the first thing we should do here is follow their instructions and plug in 9 for x. Let's go ahead and write this in, but with 9 in for x. The square root of k plus 2 minus 9 equals 0. Let's do some algebra to isolate k. We first add 9 to both sides. So we have the square root of k plus 2 equals positive 9. To undo the square root, we square the whole thing, both sides, and we're left with k plus 2 equaling 81. Finally, we subtract the 2 from both sides, and k equals 81 minus 2, or 79. Now, let's go ahead and utilize the side door method. This is not that complicated, but all we're doing is, for our second step, plugging in our values. So the first step is the same. We plug in 9 for x. The root of k plus 2 minus 9 equals 0. Let's start by plugging in 1. The root of 1 plus 2 minus 9 equals 0. We have root 3 minus 9 equals 0. Root 3 is an irrational number. Whatever it is, it's not 9, so that's wrong. Let's try 7. Root 7 plus 2 minus 9 equals 0. 7 plus 2 is 9, so root 9 minus 9. Root 9 is 3. 3 minus 9 is negative 6. It's not 0. We can cross b off as well. Let's try 16. The root of 16 plus 2 minus 9 equals 0. This is the root of 18 minus 9 equals 0. Again, root 18 is an irrational number. Whatever it is, it's not 9, so that's out. And finally, let's try what we know to be the right answer. Root of 79 plus 2 minus 9 equals 0. Well, 79 plus 2 is 81, and we know that the root of 81 is 9. 9 minus 9 is 0. All right, we got the right answer. Moving forward to number 6. Which of the following is equivalent to the sum of the expressions a squared minus 1 and a plus 1? Well, this is a pretty simple question. It's asking you to add both binomials to each other. Let's go ahead and do that. We have a squared minus 1, and to it we are adding a plus 1. All we can really do is combine like terms. A squared has none. Negative 1 and 1 are like terms. And actually, negative 1 plus 1 is 0. So they cancel each other out. All we're left with is a squared plus a, which is option A. Now, there is a side door method here, and that involves plugging in a number for a. Now, a is not a constant, it is a variable. We can plug in whatever we want. As I often suggest, let's plug in 2. A equals 2. So we have a squared minus 1. What is a squared minus 1 when a equals 2? Well, that'll be 2 squared minus 1. That's 4 minus 1. That's 3. And what is a plus 1 when a equals 2? That's 2 plus 1. Also 3. What is the sum of a squared minus 1 and a plus 1? Otherwise known as, what is the sum of 3 plus 3? Well, it's 6. Let's see which of these, when you plug in 2 for a, equals 6. So, option A, we plug in 2 for a. We have 2 squared plus 2. That equals 4 plus 2, which is 6. Ta-da! But we have to check all 4. That is the deal we made. With B, we plug in 2 for a, where we have a cubed. That's 2 cubed minus 1. 2 cubed, as you guys know, is 2 times 2 times 2. That's 8. Minus 1 is 7. That is not 6. We cross it out. We look at option C, 2a squared. That'll be 2 times 2 squared. 2 squared is 2 times 2. It's 4. This is 2 times 4. That's 8. We're getting further away. And then finally, we look at option D, which gives us a cubed, or 2 cubed. 2 cubed is 8. Also wrong. So, either way you try it, correct answer is A. Okay, these long word problems are challenging because there are a lot of words. Think of these more as reading questions, not math questions. How do you tackle this? Well, you gotta read everything. Jackie has 2 summer jobs. She works as a tutor, which pays $12 per hour, and she works as a lifeguard, which pays $9.50 an hour. She can work no more than 20 hours per week. That's an important term, no more than. But she wants to earn at least $220 per week. Which of the following systems of inequalities represents the situation in terms of X and Y, where X is the number of hours she tutors, and Y is the number of hours she works as a lifeguard? Let's make that clear as well. X is tutoring hours, and Y is lifeguard hours. Okay. So like I said, no more than is a very, very important term. If you think about what no more than means, well, that means at most, right? What does at most mean mathematically? It means less than or equal to. So we know we are looking for an option that says less than or equal to 20. Let's cross off the ones that don't have that. Look how A says greater than or equal to 20. That's the opposite of what we want. We already know A is wrong. B does have X plus Y is less than or equal to 20. We have the right symbol. We keep it. As does C. We also keep it. D has the wrong symbol. X plus Y is greater than or equal to 20. That is the opposite of what we want. We cross it off. And then, for this one, it says at least 220. Well, if no more than means less than or equal to, at least means greater than or equal to. At the very least, it can be equal that or greater. So we are looking for something that says greater than or equal to 220. Which one says it? Not B, definitely C. C is our answer. We move on to number 8. Again, a long word problem which requires a full read-through. But as we read, I'm going to challenge you to tell me, what kind of a function are we dealing with here? In air, the speed of sound s in meters per second is a linear function of the air temperature T in degrees Celsius and is given by s of t equals 0.6 T plus 331.4. Which of the following statements is the best interpretation of the number 331.4 in this context? Looks kind of complicated, but I ask you, this function right here, what kind of function is it? Pause the video and see if you can tell me. So, this is a linear function. I hope you notice that this looks a lot like y equals mx plus b. Now, this question is asking you, what does a 331.4 represent? Well, if you compare it to the linear function right here, the linear model, it looks like 331.4 is like b, the constant. The constant that represents the y-intercept. 331.4 is the y-intercept. Well, basically the s-intercept of this graph. When we are thinking of linear functions and what they represent, a y-intercept is best understood as a starting point. We are looking for the option that explains that 331.4 is a starting point of some kind. Let's look at our options. The speed of sound in meters per second at 0. Well, when t is 0, that sounds like a starting point. A is probably our answer, but let's keep going. B, the speed of sound in meters per second at 0.6 degrees. 0.6 is not a starting point. 0.6 is actually the slope of this function. Irrelevant. C, the increase in the speed of sound in meters per second that corresponds to an increase of 1. Well, words like increase do not mean y-intercept. They mean slope. For that reason, both C and D are out. They want the y-intercept, means they want the starting point. A is our answer. Now for a question like this, which is complicated, there is a side door option, and it is considering every single option and figuring out what they mean. A says the speed of sound at 0. Well, let's plug in 0 for t and see if you get 331. S of 0 equals 0.6 times 0 plus 331.4. 0.6 times 0 is 0, and 0 plus 331.4 is 331.4. A is actually true. 331.4 is the speed of sound when t equals 0. It's correct. If you try this out with option B, you'll see it doesn't work. What is S of 0.6? Well, that's 0.6 times 0.6 plus 331.4. 0.6 times 0.6, well, that's 0.36 plus 331.4, I guess is something like 331.76. Well, it's close, but it's definitely not what we want. So, incorrect. C, the increase in the speed of sound in meters per second that corresponds to an increase of 1 degree Celsius. Well, what happens when you increase by 1 degree? If you plug it in, you'll see that it increases by 0.6, not by 331.4. And for option D, the increase of the speed of sound in meters per second that corresponds to an increase of 0.6 degrees? Well, let's plug in an increase of 0.6 degrees. We just figured out that that increase is 0.36, definitely not 331.4. By this process of elimination, we know the answer is A. Now with number 9, looks like we have a system of equations, y equals x squared, 2y plus 6 equals 2 times x plus 3. Notice they're asking for not x, not y, but x times y. So we ask ourselves, what kind of functions do we have? Up top we have a quadratic function. On the bottom this is a linear function. And it looks like we have to solve for both x and y. Let's do it by substitution. If y equals x squared, we can plug in x squared for y over here. So we just rewrite the second equation with x squared in for y. 2 times x squared plus 6 equals 2 times x plus 3. Let's go through every step. Rewrite the left side here and distribute the right side. 2 times x plus 3 is 2x plus 6. We can subtract 6 from both sides. That cancels out. We're left with 2x squared equals 2x. We can divide both sides by 2. And we're left with something very simple. X squared equals x. Since this is a quadratic function, the best thing is to make it equal 0. Move that x over to this side by subtracting it. We have x squared minus x equals 0. Let's go ahead and factor. Take out an x, we're left with x minus 1 equals 0. We now assume both these factors equal 0, x equals 0, and x minus 1 equals 0. So we have one solution, x equals 0, and now we solve for this one by adding 1 to both sides, and x equals 1. So x equals 0 and x equals 1, but take a look. We are told that x must be greater than 0, so we can only consider one of the options. X is definitely 1. Okay, that's helpful. Now if x is 1, what is y? Let's plug it into that original equation. If y equals x squared, well, then y equals 1 squared, or just 1. X is 1, y is also 1. So what is x times y? Well, 1 times 1 indeed is 1. There's our answer. Moving down, we have number 10. The test is starting to get a bit difficult, but that's okay. There are several ways of solving a hard problem like this. If a squared plus b squared equals z, and ab equals 9, which of the following is equivalent to 4z plus 8y? Well, the first thing we do is notice that all of our answers are in terms of A and B. So perhaps our answers should be in those terms as well. We should solve in terms of A and B, not Z and Y. Let's substitute both this Z and this Y with their respective values in terms of A and B. So 4Z becomes 4 times, well, whatever Z is, A squared plus B squared. And then we have plus 8Y, which we know now is A times B. Now, let's figure out what this is. Let's distribute. 4 times A squared plus B squared is 4A squared plus 4B squared. And 8 times AB is just 8AB. What if we switch this around so it looks like this? 4A squared plus 8AB plus 4B squared. The reason I like this is because it now looks like a perfect square trinomial, which, if you look at your options, these are all factored versions of perfect square trinomials. We know it's a perfect square trinomial because both the first term and the last term are perfect squares, 4A squared and 4B squared. So let's see if it factors into something nice. Well, what is the root of 4A squared? Well, it's 2A. What is the root of 4B squared? It's 2B. And everything is positive here. Let's see if when we multiply this out, we get this. Well, 2A times 2A is 4A squared. 2A times 2B is 4AB. 2B times 2A is also 4AB. And 2B times 2B is 4B squared. If we combine our like terms here, we have 4A squared plus 8AB plus 4B squared. Well, it looks like our answer is 2A plus 2B times 2A plus 2B, or otherwise 2A plus 2B squared. That's option B. But never fear, there might be an even easier way. If we employ our plug-in rules here, let's pick values for A and B. As always, let's start with 2. We'll say A equals 2. And for simplicity's sake, we'll say that B equals 3. Let's solve for Z and Y as real numbers. If Z is A squared plus B squared, well, we have 2 squared plus 3 squared. That equals 4 plus 9. That means Z is 13. Let's write that down. And if Y is A times B is 2 times 3. That's 6. Y equals 6. We have our values for Z and Y. Z is 13 and Y is 6. So what is 4Z plus 8Y? Well, let's plug it in. 4Z will be now 4 times 13, and 8Y will be 8 times 6. Now, we don't have a calculator, so let's do some actual math here. 4 times 13 will be 13 times 4 here. 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 is 5. This is 52. And 8 times 6 is 48. 52 plus 48 is a nice round 100. That is going to be useful. So we know with our desired values, 4Z plus 8Y equals 100. Which of these options equals 100 when A is 2 and B is 3? Well, let's start with option A. Option A says A plus 2B squared. Well, A is 2. 2 plus 2 times 3 squared. We end up with 2 plus 6 squared. That is 8 squared. 64. No good. A is out. We then move to option B. 2A plus 2B squared. Well, A is 2 and B is 3. All this squared. Well, 2 times 2 is 4. 2 times 3 is 6. 4 plus 6 squared, or 10 squared, indeed is 100. We know that's the answer, but let's check the other two just in case. 4A plus 4B squared, we can look at it as 4 times 2 plus 4 times 3 squared. That's going to be 8 plus 12 squared. That's a huge number. 20 squared. That's actually 400. No good. Just for kicks, let's try D. That's 4a plus 8b. So it's going to be 4 times 2 plus 8 times 3 squared. 4 times 2 is 8. 8 times 3 is 24. We get 32 squared. I don't even want to solve for that. I know it's way bigger than 100. So our answer must be B. The volume of right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? Sounds complicated, but don't forget, they do give you the formulas for certain geometric problems, and one of them is the volume of a cylinder. You'll see at the top of the test that the volume of a cylinder equals pi r squared times h, r being radius, h being height. So cylinder A, we know, has a volume of 22 cubic centimeters. So 22 equals pi times r squared times h. Well, not sure what r and h are, but they somehow get us a volume of 22. What's going to happen if we double the radius and halve the height? The radius, which was once just r, now becomes 2r. The height, which was once h, now is h over 2. So let's plug these in to the volume function. The volume is going to be pi times r squared. R is now 2r squared times h. That's h over 2. Let's do some expansion. This is going to be pi. 2r squared is actually 4r squared. And h over 2 stays as h over 2. Let's combine like terms. We now have 4 pi r squared h over 2. And we can reduce this to 2 pi r squared h. Now, this doesn't look like an answer, but if you compare it to cylinder A that has pi r squared h and a volume of 22, well, this looks like it's exactly double this. It's 2 times pi r squared h. Therefore, what's double 22? Well, 22 times 2 is 44. There's our answer. But there is a side door method of getting this question, so buckle up. So, it does require us to have that volume formula. Volume equals pi r squared h. And of course, we plug in 22 for the volume. So 22 equals pi r squared h. Now, we need to plug in our own values for radius or height and then solve from there. Let's just make up a radius. Let's say the radius here is 1. It's a radius of 1. Pretty simple. So we plug that in to here. 22 equals pi 1 squared times h, which is pretty simple. We just then know that 22 equals pi times 1 times h, or pi times h. So if you want to solve for the height, it now becomes, well, divide both sides by pi. Height is 22 divided by pi. We now have our values for the radius and height for cylinder A. We made them up, but they check out. So now, let's do what the question asks. Twice the radius. Twice of 1 is 2. New radius is now 2. And half the height. What is half of 22 over pi? Well, 22 over pi times 1/2. Cancel out these. We end up with 11 over pi. Okay, let's go ahead and insert these two measurements into the original volume equation. V equals pi r squared, or 2 squared, times h, or 11 over pi. Well, Let's simplify. Pi times 2 squared is 4 pi times 11. That's going to be 44 pi over pi. Cancel out the pi's. You get 44. Just like that, by plugging in your own values for radius, getting height, plugging them into the new equation, you still get the right answer. Okay, moving forward to number 12. Which of the following is equivalent to 9 to the power of 3/4? Remember that for fractional exponents. Let's say you have x to the power of a over b. This turns into the following: the b root of x to the power of a. Let's apply that to 9 to the power of 3/4. Well, that would mean 9 to the power of 3/4 would be the 4th root of 9 to the power of 3. Okay, well, that was simple enough, but none of our answers is that. This has the 4th root of 9, but not 9 cubed, so that's out. And this has the cube root of 9. Definitely not the 4th root of 9. That's wrong. So something is funky here. We look at our remaining answers and they contain 3. What does 3 have to do with 9 to the power of 3/4? Well, if we're talking about exponents, 9 can be rewritten as an exponent itself. 9 is an exponent of 3. What is 9? 9 is 3 squared. Let's rewrite this with 9 as 3 squared. Instead of 9 to the 3/4, we have 3 squared to the power of 3/4. And don't forget, when you have an exponent of an exponent, you multiply them. This becomes 3 to the power of 2 times 3/4, which is 3 to the power of 6/4. And let's reduce this by a factor of 2. We get 3 to the power of 3/2. This we can convert to a radical. This becomes, well, the square root of 3 cubed. Still not exactly what we have here. But let's simplify this. 3 cubed we know is 3 times 3 is 9, times 3 is 27. This is the root of 27. We can now break this up into the root of 9 times the root of 3. Because you know 9 times 3 is 27. What is the root of 9? It's actually 3. The answer to this is 3 times the root of 3. An advanced problem, yet a satisfying solution. We then look at number 13. At a restaurant, n cups of tea are made by adding tea bags to hot water. If t equals n plus 2, how many additional tea bags are needed to make each additional cup of tea? That's very wordy, but the most important part here is the function. What is this? T equals n plus 2. I hope you have realized is a linear function. Kind of looks like y equals mx plus b. And we ask ourselves, what is this question asking? Is it about slope or about y-intercept? Well, the question says how many additional tea bags are needed to make each additional cup of tea. That sounds like rate of change. That is a slope question. All this question is asking you is, what is the slope of this line? Well, what is the slope of this line? T equals n plus 2. The slope is 1. Now, there is a side door method here. Let's figure it out. We focus on this function, t equals n plus 2. They want to know how many tea bags are needed for every additional cup of tea. Well, let's make up a number of cups of tea. Let's say I'm currently making 2 cups of tea. N equals 2. Well, let's figure out what t is when n equals 2. T equals n plus 2, so t equals 2 plus 2. When n is 2, t is 4. Okay, when n is 2, t is 4. So let's make an additional cup of tea. Instead of 2 cups of tea, I'm now making one more. I'm making 3 cups of tea. N equals 3. So we plug it in. T equals n plus 2. T equals 3 plus 2. T equals 5. And look, 5 is exactly 1 more than 4. We still have our right answer. So now we look at number 14. We have a very advanced function, exponential function. F of x equals 2 to the power of x plus 1. The function f is defined by the equation above. Which of the following is the graph of y equals negative f of x in the xy plane? Well, if we're familiar with exponential functions, we know that 2 to the power of x looks kind of like this. It crosses at 0, 1, and it increases, never going below the x-axis. And then, if we apply the vertical shift up 1, the whole thing gets moved up 1. Where instead of crossing at 0, 1, it now crosses at 0, 2. But that is not what they're looking for. They're looking for the negative version of this. We're looking for the function that is the reflection over the x-axis. So instead of increasing, it's going to be decreasing, and instead of crossing at 0, 2, it crosses at 0, -2. Which of these options looks like this? Definitely not A, that's above the x-axis. Definitely not B, that is increasing. C looks pretty good. It crosses at -2. And D does go above the x-axis. It is out. The right answer is C. But perhaps this question is better taken by the side door method. What if we found negative f of x first? Well, if f of x is 2 to the power of x plus 1, negative f of x would just be negative 2 to the power of x plus 1. Distribute the negative, you get negative 2 to the power of x minus 1. Well, if y equals this, let's just try to plug in a value we know. Let's plug in 0 for x. So, y equals negative 2 to the power of 0 minus 1. What is 2 to the power of 0? Anything to the power of 0 is 1. Y equals negative 1 minus 1. Negative 1 minus 1 is -2. So we know when x equals 0, y equals -2. This point must definitely be on the graph of negative f of x. The only option that contains 0, -2 is C. Here it's 2, here it's -1, here it's also -1. We now look at number 15, in some ways the hardest question on this test, but made easier when you realize that you're given a lot of information here, some of which is unnecessary. Let's read. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5, assuming gasoline costs $4 per gallon. Which equation can Alan use to determine how many fewer average miles M he should drive each week? Yikes. Well, here is a hint. If you look at all your answers, the numbers that have been represented are 25, 4, 5, and 95 for some reason. Well, we never see 100. And the reason is 100 is irrelevant. It doesn't matter how much he drives. If you're asking how many fewer miles he has to drive to spend less money, it doesn't matter how much he's already driving. He could be driving 5 miles or 1,000 miles. So, for all intents and purposes, let's ignore this first part. All we care about is how many miles you get per gallon and how much each gallon costs. Right now, you can drive 25 miles per gallon, and each gallon costs $4. So essentially, you spend $4 to drive 25 miles. Alan wants to know how many miles $5 buys you, because that's what he wants to save. So, $4 is to 25 miles, as $5 is to M miles. Which of these options is a version of this? Well, we know it's not the ones with 95 because we don't see a 95 here. Cross A and C out. And it looks like we want to isolate 5, so let's multiply both sides by M. We end up with 4 over 25 times M equals 5. D is our answer. For number 16, we have a nice word problem with money. It means we probably need an equation. Maria plans to rent a boat. The boat rental costs $60 per hour, and she will also have to pay for a water safety course that costs $10. So that sounds like it's saying $60 per hour plus a $10 safety course. Marie wants to spend no more than means less than or equal to $280. What is the maximum number of hours for which Maria can rent the boat? Let's go ahead and solve for H. Subtract by 10. 60H is less than or equal to 270. We're solving for H, so let's divide by 60. So H is less than or equal to 270 over 60. I'm not sure what that is, but let's see if we can reduce. Divide by 10. H is less than or equal to 27 over 6. I guess we can divide by a factor of 3. So H is less than or equal to 9 over 2. That's about 4.5. Well, if it's a whole number of hours, well, the maximum number under 9/2 is 4. The answer here is 4. Okay, we move on now to number 17. What value of P is the solution of the equation above? This looks pretty simple as long as we're careful with our distribution. 2 times P plus 1 is 2P plus 2. 8 times P minus 1 is 8P minus 8, of course, equaling 5P. Let's combine like terms. 2P and 8P is 10P. 2 minus 8 is negative 6, equaling 5P. Okay, let's subtract 10P from both sides to combine like terms, and we get negative 6 equals negative 5P. And to isolate P, we divide by negative 5. P equals negative 6 over negative 5, which of course the negatives cancel out and we get 6/5. That's our answer. Now looking at number 18, it looks kind of complicated, but it is two linear equations. What's the value of x? This is pretty simple. All we have to do is plug in 2x in for y. So 1/2 times 2x plus 2x, because y is 2x, equals 21/2. Well, that's 1/2 times 4x equals 21/2. 1/2 times 4x, 1/2 of 4 is 2. So 2x equals 21/2. Let's divide by 2. That becomes 21/2 times 1/2, or 21 over 4. We now look at number 19. And it says this expression here is equivalent to a over x plus 2 squared. It's important to write that down. What is the value of a? Well, it's a constant, so we can't plug in for that. But we can notice that this subtraction can happen as long as there is a common denominator. Make it x plus 2 squared. Let's rewrite this. The first expression stays as is. The next one, so that it is a fraction on top of x plus 2 squared, we multiply both top and bottom by x plus 2. And then the right stays as is. Let's combine this left side as one fraction. So we have 2x plus 6 minus 2 times x plus 2 equaling a over x plus 2 squared. Now look, we can cancel these two out because they're equivalent. So 2x plus 6, let's go ahead and distribute this negative 2, minus 2x minus 4 equals a. And now look, combine like terms. 2x minus x, that's 0. 6 minus 4, that's 2. A equals 2. Simple as that. But wait, there is a side door option for number 19. Let's check it out. Remember how we said you can plug in for variables, but you can't plug in for constants. And look, it says x does not equal negative 2. Well, let's plug in something besides -2. What do we always plug in? We plug in 2. Let's say x equals 2. Well, let's do it. 2 times 2 plus 6 over 2 plus 2 squared minus 2 over 2 plus 2 equals a over 2 plus 2 squared. Let's figure this out. 2 times 2 is 4, plus 6 is 10. 2 plus 2 is 4, squared is 16. Minus 2 over 2 plus 2 is 4. And here we have a over 2 plus 2 squared. That's 4 squared. That's 16. Let's see if we can find a common denominator here. 10 over 16. Hey there, buddy. I'm doing math. Okay. 10 over 16 and 2 over 4. Let's use 16 as a common denominator. We have 10 over 16 and multiply by 4. That's going to be 8 over 16 equals a over 16. 10 minus 8 over 16 is going to be 2 over 16 equals a over 16. Multiply both sides by 16 to cancel it out, and just like before, a equals 2. Intersecting lines R, S, and T are shown below. What is the value of x? Let's not forget that we find supplementary angles in a straight line and in a triangle. What can we fill out? Well, we know this angle is supplementary with 106. What is 180 minus 106? Let's cross that out. We get 474. And we know now that these three angles must add to 180. So 74 plus 23, that's going to be 97. If these two add to 97, this one has to be 83. And if this angle is 83, x must be 83 supplement, and 180 minus 83 is 97. There is our answer. All right, guys, thank you for joining me. That was section 3 of practice test 5. Have an amazing week, and join me next time for some trigonometry.